Hello all, in this previous session, we understood about regression analysis and how important it is in supervised learning. Now in this session, we're going to start with the regression techniques, the types of regressions, such as linear regression and multiple linear regression. Let us start with this. Now, let us start with the linear regression. Once again, recall that regression is a statistical method to model and analyze the relationship between the variables, dependent variables and independent variable. We just try to define a relationship in between the variables. In the linear regression, we can plot a straight line in between the variables. Okay, it just will show you a straight line, right? The model's relationship in between two variables with a straight line. Let us say y is equal to mx plus c. Okay, it is a pretty widely used regression, the formula, right? Y is equal to mx plus c. Similarly, there is something called y is equal to b naught plus b1x into e. This is another linear regression formula for an instance. It's a regression formula. Now here what is that? Y is a dependent variable. Here the value of y is a dependent variable. X is the independent variable. And now we just start defining the difference, rather the relationship in between y and x. Now b is the intercept and b1 is the slope. B is the intercept, b1 is the slope. And a is something called the error term. There is maybe an error. In predicting the outcome, there may be a slightest error. We should also be join that error into the entire equation, which makes our regression equation. Okay. With respect to multiple linear regression, this will slightly be increased. Here there is a y, and here the independent variables are in multiple number. It is not a single x. There are multiple independent variables which is going to affect the value of a dependent variable y. So this is b0 plus b1x1, b2x2 and so on, bnxn into e. This is how the multiple linear regression will get calculated. There is also something called logistic regression, which is used when the dependent variable is binary. Okay, dependent variable is when completely binary. We will go for the logistic regression. We are going to clearly understand each and every regression technique in the complete upcoming sessions. Then models the probability using a sigmoid function. In the logistic regression, we are going to use a sigmoid function to model the probability. Okay, we are completely going to understand the logistic regression. Now, what will be the basic assumptions in the linear regression? Now, the first thing is the relationship in between dependent and independent variables are linear. Only a straight line can divide the relationship. Okay, and the independence. The variables are independent of each other, except y, all the variables are independent of each other. This is another thing. Is constant variance of residuals. We will understand this constant variance of residual take an example, and normality of residual also we will understand using a simple example. Now, what are the key metrics in regression? There is something called R squared. Measures how well the independent variable explain the variation in the dependent variables. What is R square? R square will talk about how well the independent variable explain the variation in the dependent variable. There is a independent variable y. If you affect y, there is, let us say, y is equal to mx plus c. Okay. Now what is x? X is an independent variable, right? How x can actually define y? How well x can actually define y? If there is a variation in x, does y will seriously be affecting or somewhat a little is being affected? So that will be measured by R square. It measures how well the independent variable explain the variation in the dependent variable. R square is equal to 1, perfect fit. R square is equal to 0, no fit. If R square is equal to 1, it's a perfect fit. The line is going to be perfect fit. If the R square is equal to 0, the line will not be perfect fit. Anyhow, we get going to understand this R squared. The coefficients indicate the strength and direction of the relationship in between the variables. Okay. Residuals and p-values, we already know what is a p-value. In the previous session, we understood the p-value. Okay. Let us take a simple linear regression. By this example, it will completely be clear. It will completely be crystal clear what exactly is the linear regression, how it's going to act. Now, let us take a data set. In this data set, we have two parameters. One is hours studied and exam score. Now, how well hours studied is affecting the exam score. Here, this will become X, independent variable. This becomes Y, it's a dependent variable. Because hours of study will always be independent, but that will contribute towards Y. Okay, now the scenario is we want to predict the student's exam score Y based on the study hours X. Okay, now initially we need to fit the regression model Y is equal to B0 plus B1X. Here let us ignore the term error for some time. Now, what is B0, what is B1X? Let us see. Now initially we need to calculate the covariance. You know what is the covariance? How to calculate the covariance? B1. Just if you forget the covariance, just recall my previous session, just go access my previous sessions in which you will understand what is the covariance. Okay, so B1 is equal to, then after, initially we need to calculate the quotients. Right after you calculate quotient, B1 will be covariance of X comma Y divided by variation of X. Okay, so then B0 will be equal to Y mean minus B1 into X mean. Y mean minus B1 into X mean. After the calculation, B0 will come to 45, B1 will come to 6. Okay, predictions. If for X is equal to 3 hours, Y is equal to 45 plus 6 into 3, which is equal to 63. For X, let us understand X is equal to 3 hours, then Y will be equal to 45 plus 6 into 3. What is Y value here? The Y value here is B0 plus B1X, right? What is B0 calculated B0? The calculated B0 is equal to 45. For that, you should be able to calculate this. Covariance and variance of X. Covariance of X and comma Y, variance of X. Right after which, you get B1 is equal to, B0 is equal to 6. And B1 is equal to, just a minute. Yeah, it is B0 is equal to 45, this is 45 and B1 is equal to 6. Now, when X value is equal to 3, then Y is equal to B0 plus B1X. B0 is 45, B1 is 6 into 3 is equal to 63. Well, it model fit. Now, when you compute R square, it measures how well the model predicts Y. Okay. Now, the key differences between hypothesis testing and regression, if you have a look at, hypothesis testing tests if the hypothesis about data is true. But regression states model and predict relationship in between two variables. There is ambiguity in between what exactly hypothesis test and what exactly is the regression does. Hypothesis is more about to predict, rather to identify if the hypothesis is true or not. But regression is going to identify the relationship in between the data points, independent variable and a dependent variable here. The focus of the hypothesis testing will be on H0 and H1. Here the regression estimating coefficients and making predictions. We just are going to identify the the coefficients, and finally we'll be able to make the predictions. And output will be p-value decision, either to reject or accept it. And here we need to regression evaluation, R square and coefficients. Applications, comparison and testing, prediction and understanding the variable relationship. This is the key difference in between hypothesis testing and a regression. Thank you.